At the end of this video, you should be able to solve the LP, that is linear programming problem, by using simplex method. Here are the steps for solving the LPP, that is linear programming problem, with the help of simplex method. There are various methods and simplex method is one of the methods to solve the linear programming problems. The first step is to convert the linear programming problem that is given to us into a standard form. Next is to create an initial table. Then establish the initial feasible solution. So initial feasible solution is the solution which satisfies all the constraint. Then look for any scope for improvement, whether initial feasible solution is optimum or not. If it is not optimum and there is a scope for improvement, then we will identify the entering variables and also we will identify the departing variables, and then we will iterate it until the optimum solution is reached. This is the linear programming problem that we wish to solve. So we have two decision variables, that is x and y. So values of this x and y we need to compute, and we have to maximize this objective function. So 3 is the profit by making x and y, 5 is the profit by making the y product, and it is subjected to constraint. Now there are 3 constraints and each constraint is related to one resource. If you are not aware of how to formulate the linear programming model out of the problem statement, you can see another video. Link is available in the description section. So as you can see that all the constraints are of less than or equal to type, right? So we can see that there are 3 constraints and all the 3 constraints are of less than or equal to type. Now we need to convert this constraint, that is inequalities, into equalities by adding certain slack variables. So what is slack variable? So slack variable is an variable which represents the unused resource. So for every constraint we will add one slack variable. So as we have 3 constraints, we will be adding s1, s2 and s3, 3 slack variables, and these 3 slack variables represents the unused resources. So my objective function will remain same, and I will add s1 to this first constraint. So s1 I have added and I have converted this less than or equal to sign into equal to sign. Next I will add s2, that is the slack variable 2 for the second constraint, and third I will add s3 in the third constraint. So I have converted all the inequalities into equalities. Now I need to convert this linear programming model into standard form so that we can create the tabula. So this is the one that we have updated right now. I will keep the slack variables as same. Now can I write this objective function in terms of this s1, s2 and s3, as the slack variables are not contributing because they are the unused resources, right? So they are not contributing anything in the profit, so their coefficient will be 0. So their profit coefficient will be 0. But to create a standard form we have to write it like this. Then let us move to the constraint. Now we have to represent every constraint and we have to add 3 slack variables in every constraint. So this is first constraint, that is x plus 2y plus s1, and other 2 constraints I have added, but added as a coefficient as 0. So it will go it will come to an 0 only, but I have represented in this way so that I can create the standard table for the LPP. Similarly, in second constraint, now I have added 0 coefficient for S1 and 1 coefficient for S2, right? So you can compare this over here. And in third constraint, I have added this 1 coefficient for this S3 and other two S1 and S2 are 0. This is my standard linear programming model which I need for preparing the table which is required for the simplex method. Now let us move to the simplex method table. Now this is the blank table and we need to fill up the values. The blank table template is available in PDF format and the link is provided in the description section. Now let us pull the objective function, and this is the standard format of an LPP that we have just computed. So there are 5 variables, so x, y that we need to compute, and S1, S2 and S3 are the slack variables. Now let us put these variables into this table. So I have now 5 variables, right? And I will also put the coefficient of each variable, okay, which is the value of Cj in the respective cell. So 3, 5, 0, 0 and 0. So this becomes my coefficient of the variables. Now we need to understand the term what exactly mean by basic variables. So in this table of simplex, the basic variable represents those variables out of these 5 variables which are currently there in the solution. Now initially we assume that the value of x and value of y is 0, and we take all the slack variables, that is S1, S2 and S3 in our initial basic feasible solution. So basic solutions are those variables which are currently present in the simplex table, and in initial stage we take all the slack variables as our basic variables. So I am adding S1 over here, S2 and S3, and their Cj value, right, that is profit coefficient, are 0. So I am representing this 0 over here. Now the next column is the solution RSH, right? That's right hand side of the solution, right, that I have added. This is the replacement ratio which we need to decide the key row and key column, right? And this is the Zj, which is nothing but the profit, and Cj minus Zj, this is the term on the basis of which we are going to decide whether the obtained solution is optimum or not. So with this table we will start working on it. Now let us pull our constraint and fill this table. So we have 3 constraints and we have these 3 particular rows that we need to fill. Now each row represents 1 constraint. So this is the constraint which is having the slack variable as S1. This is the constraint which is having the slack variable S2, and this is the constraint which is having the slack variable as S3. So the first constraint will be go to the first row, and this will be x will represent this particular x. So this coefficient of x is 1, so I will be writing 1 over here. The coefficient of y is 2, so 2 over here. 1 S1 coefficient is 1, and S2 and S3 coefficients are 0, and on the right hand side I have this 2000 value. So on the right hand side of equation there will be an 2000. Similarly, the same values will be repeated for the second constraint and it will be repeated for the third constraint. So for third constraint I do not have any x over here, so x will be 0, y is 1, 0, 0, 1 and 600. So I have now marked all my constraint. Now it is time to calculate the value of Zj. So what is Z? Z represents the profit. Okay, now at this point let us try to calculate the profit. Now how do I calculate the profit? The profit is given by, we have to calculate the profit for a particular column, and this is given by this particular variable into this profit coefficient plus this particular variable and the profit coefficient and this particular variable. I need to add plus over here and into the coefficient, profit coefficient. So the multiplication of these two plus multiplication of these two value plus multiplication of these two value, so it will give me a 0 plus 0 plus 0. Okay, so I will add 0 over here. Similarly for second column it will be 0 plus this 0 plus this 0, because there is a multiplication of as all these values are 0, so obviously multiplication value is going to be 0, so there will be a 0 value. Similarly I can compute the values for the rest of the column. Now I need to compute this Cj minus Zj value. So what is this Cj minus Zj value? So this is your Cj value minus this Zj value. So 3 minus 0 will give me a value of 3. Similarly, this particular 5 minus 0 will give me a 5. 0 minus 0 will give me a 0 value. 0 minus 0 will give me a 0 value, and 0 minus 0 will give me a value of 0. Okay, now the next thing is to look for the opportunity. Now this Cj minus Zj gives us opportunity to improve the solution. If any value between this row, okay, so anything in this row, if it is positive, that we have a scope to improve and we have to select the maximum value. Okay, so this particular column represents this 5 Cj minus Zj value, which indicates that we have a opportunity to improve this solution, and this corresponding variable, that is y, is going to enter into the solution, and that is why we call it as a key column. Okay, so I will mark the column with highest value of Cj minus Zj as a key column, and y will become my entering variable. Now in this basic variable, y is going to replace any one of these three variables, and we have to find out to whom it will replace. To find out that, we have to find out the replacement ratio. Now the replacement ratio is given by this right hand side value divided by element in the key row. So 2000 divided by 2 will give me a value of 1000. Similarly, this 1500 divided by 1, okay, so this element in the key column will give me a 1500 value only, and for this particular row 600 divided by this 1 will give me a value of 600 only. Now we are ready with the values of this replacement ratio. Now here you have to look for the replacement ratio value which is having a minimum value. So this particular row is having the minimum value of replacement ratio. What is the meaning of that? This will become your key row, and this S3 will be the departing variable. So we have seen that y is the entering variable, so y will take place of this S3. Okay, this is the meaning of all these things, right? And my this element 1 is of very important because we need this particular one for computing the rest of the few values. So the one I call as a key number. Now we are at iteration number 1 and you have to prepare the same table for this iteration. Only change will be at the place of S3 there will be now Y, because Y is the entering variable and S3 was the departing variable, and the coefficient of Y is 5, so I am 5 writing over here. Now we have to fill this table, all the elements in this table based on the values and some formula from the previous table. So I will pull out the key row from the previous table. So this is the key row from the previous table and we want to transform this key row into new row at the same location but with certain modification, and that modification is new element in this row will be given by corresponding element in the key row. So corresponding element from the previous row divided by the key element and key element from the previous table, right? So here I can write that 0 divided by 1 will give a new value over here as 0. 1 divided by 1 because the key element is 1 and we are dividing it by 1 only, so this will give me a value of 1. Again this 0 divided by 1 will give me value of 0, and 0 divided by again 1 will give me a value of 0, and 1 divided by 1 will give me a value of 1. Now you remember that this particular row we are fetching from the previous table. Okay, now and the last element is this 600 divided by 1 will give me a value of 600, right? And we are putting all these values in corresponding places. Okay, now moving to the remaining cells. Now to evaluate these two remaining cells, we have to use the different formula. Now this is the same cells from the previous table. These are the same rows from the previous table and we have to use this formula. Now new element of the replaced row. Now this we call it as an replaced row is given by element in the old row. So element in the old row that we have to take the reference minus intersecting element of the old row. So if you remember that this was the key column, so this was the key column from the previous table, so and this is the intersecting element of that particular column and row into corresponding element in the reduced key row, and we have to consider this also. So let us take one example over here. Now this one is coming from element from the old row, right, minus intersecting element of the old row. So this 2 will be go over here into corresponding element in reduced row, into corresponding element in the reduced row. Okay, so that will give me a complete value of 1, right? Similarly we will calculate the remaining elements. So for this particular element, let us calculate it. So this will be, this 2 is from the previous table, okay, element in the old row minus again the same is the intersecting element, right, and this one is from this particular row that we have just evaluated, and that answer is 0. Similarly we can go for the remaining things, right? Let us see this procedure for this last element also. So here this 2000 is coming from the old table, right, and this 2 is as an intersecting element from here, and this particular 600 is coming from this particular value, which is the reduced key row from the current table, and this complete value will be given by 800. Similarly, now I need to pull the second values for this particular second row, and we can use the same formula, right? And I am pulling this row little up, so the same thing we have to repeat, and we have to get the values for all these elements. Okay, and finally our table is completely ready. So I will explain one more time for this particular 900 value. So this 1500 is coming from the previous table value, and one is your this intersecting element. Now intersecting element will change as the row has changed, and this 600 is coming from the current table, which is for the reduced key row. So in this way we have computed all the values in the table, and now we are ready to go for calculating the values of ZJ. Now what is ZJ? ZJ is the profit. Now how do we calculate it? So what we do, so we make it a product of these two. So 0 into 1 plus 0 into 1 plus 5 into 0 will give me a 0. Similarly here 0 into 0, this 0 into 0 plus 0 into 0 plus 5 into 1 will give me a 5 value of 5, right? So similarly I can go for the remaining values. So if I calculate all these values of this ZJ, they are like this, and now I will compute the Cj minus Zj. Now what is this Cj? Cj value is over here. So 3 minus 0 will give me the value of 3, right? So 5 minus 5 will give me value of 0. So 0 minus 0 will give me a value of 0. So this particular 0 minus this 0 will give me a value of 0, and this 0 minus 5 will give me a value of minus 5. Now we have to look for this Cj minus Zj row, and if anything is positive in this row, that gives us an opportunity to improve the profit. Now here I get a 3 as a positive value, so this particular element is of importance, this particular row column is of importance for me, and this particular column I call it as a key column. Now what is the importance of this column is that now this x will be now entering variable, right? And now I have to decide what will be the departing variable, and that I decide with the help of this replacement ratio. So how do I calculate the replacement ratio now? So 800 divided by this particular one will give me a replacement ratio of 800 only. 900 divided by this corresponding element in the key column will give me 900 divided by 1, 900 only. And if I divide 600 divided by this 0 corresponding element 0, it will give me value of infinity. Now if you remember, we have decided that we have to select the value which is minimum for this replacement ratio, and that becomes my key column. And what is the importance of this key column? Key column will decide which is the departing variable. So this S1 is now departing variable. So this X is going to take place of this X1 for the next iteration, right? Now, and this particular one, this particular row I call it as a key row, and this one has now become my key element. Now based on this particular key row and key column and this key element, we have to now make the next table. Okay, so moving to the next table, now I have to again make a blank table. Only change is that now I have replaced S1 with this X, because X was the entering variable and S1 was the departing variable, and 3 is the coefficient of this X, right? Now we have to repeat the procedure that we have done previously. So what I am doing, I am pulling this key row from the previous table, right? So s1 was the departing variable, right? Okay, and this one was our key element from the previous table. Now, as we have seen earlier also, the new element will be given by corresponding element in key row divided by key element. Okay, so let us try to evaluate one new element, right? So it will be given by, so this particular value is 1. Okay, so this will be 1, right? Divided by key element is also 1, so that will be given as only 1, right? Similarly, if I write down this 0 divided by 1 will give me value of 0 only. 1 divided by key element 1 will be give me value of 1 only, right? So 0 divided by 1 will give me value of 0 again, and minus 2 divided by 1 will give me value of minus 2. And for right hand side, what I can do, so this 800 divided by this particular 1, and 1 is coming from this thing, so it will give me the value of 800 only, right? So now we are ready with this one row, and now we have to complete the remaining these two rows. Now for this we need a reference from the previous table. So from previous table, now I am pulling these two rows, right? So this S2 and Y, right? And I have this formula, right? Again the same formula that we used for the last iteration. Okay, now for new element, right, in this particular row, so we are looking to calculate this particular element. Okay, and then how we can calculate it now? So this particular one, so this one is element in old row, so this one is coming from here, and intersecting element in old row, again it is the same element, right, into corresponding element in reduced row. So what is our reduced row? Now this is our reduced row, and which we just evaluated. We have to take this into account also. So this one is coming over here, and that will give me the value of 0, right? So similar thing you can do to evaluate the remaining elements, right? So we will see one more time how we evaluated the last element, right? So what I will do now, so this element in old row, so element in old row is 900 over here, right? Okay, and minus intersecting element is 1, right, into corresponding element in reduced row, so this 800 will come over here, right, and that will give me value of 100 only, right? Similarly, we have to pull the element this particular row, right, and use the same formula, right? And now I will directly take all the values, right, and you can calculate it in the same way we have done previously, right? Okay, now this is the time to evaluate the value of Zj one more time to see whether all the values of Cj minus Zj are still positive. So if something is still positive, we have to reiterate the problem. Okay, now how do we calculate this value of Z? So 3 into 1 plus 0 into 0 plus 5 into 0, so that will give me a value of 3, right? So similarly I can calculate the values of Zj for the remaining elements. Now this, how do we calculate the Cj minus Zj? So this is Cj is 3 minus 3 will give me a value of 0, right? So this 5 minus 5 will give me a value of 0. 0 minus 3 will give me a value of minus 3, and 0 minus 0 will give me a value of 0, and this particular 0 minus 1 will give me a value of 1. Now we again got the value, one value positive, right? Okay, so I have a question for you people. Can you tell me what to do now? So again we have got this value 1, right? So what is the significance of this? So just pause the video and think about it. right? Okay, so I hope that you pause the video and given a thought to this. Now the meaning of this one is that as it is a positive value, we still have a scope to improve, right? Now I want to indicate few more things. Now here this value of x is coming as 800. Okay, so this is the now solution, okay, which is a feasible solution but not an optimum solution, right? So value of x is coming as 800, right? Value of y is coming as 600, okay, and this s2 is coming as 100. So what is the meaning of this s2? So still there is some unused portion, unused resources from the constant number 2, and which is 100, and the profit is given by 5400. So we have to see, by making one more iteration can we improve this profit. So you please note down this figure 5400. Okay, now moving to the next iteration one more time, but for that I need to know what is my entering variable. Now the entering variable is s3, right? So because why entering element is s3? Because this positive value and it is corresponding to this s3, and I call it as a key column. Now based on this key column I have to decide what is my departing variable, right? And how do I do that? I do it by calculating the replacement ratio. So 800 divided by this minus 2, okay, so this minus 2 will give me a value of minus 400. So this is my replacement ratio. Similarly, this 100 divided by 1 will give me a replacement ratio of 100, and 600 divided by 1 will give me the replacement ratio of 600. Okay, now you must be thinking that as we consider the most minimum value, right? So minimum value as an key row, but we should not consider any negative value in the replacement ratio. We have to consider the minimum positive value, right? So this is a very, very important point. So we have to consider departing variable that which have positive minimum value. So here 100 is having the positive minimum value. We will not consider this minus 400, and this will become my key row. What is the meaning? That s2 is the departing variable. So s3 will replace now this particular s2, right? And now we have to make one more iteration, and for which we need a fresh table. But before that, let us see our key element is, or key number over here is 1, right? So prepare the fresh table, and in this fresh table this s2 is now replaced with s3, and which is having the c value as 0, right? Now pull out the previous value of this particular s2, and which will be helpful to evaluate the new value, right? And we have to use the same formula, right? So this is my now key element. So 0 minus 0 divided by 1 will give me a value of 0. 0 divided by 1 will give me the value of 0. Minus 1 divided by 1 will give me a value of minus 1. Again 1 and 1. Okay, and 100 divided by 1 will give me the value of 100 only, right? Similarly, we have to now pull for the from previous table. We will pull the corresponding this row. So it is given by this, and the formula as we have seen previously, right? So now I will not go in details, but we will directly take the values, right? And you can evaluate it, right? Okay, and again you have to pull out the corresponding row for this corresponding row from the previous table, and with the help of this formula you can evaluate the values of for this row, right? Now I am ready with this table, right? Now I have to calculate the ZJ value. Now you know the procedure how to calculate the ZJ value, right? So I have computed the ZJ value. So what is ZJ value? How did I compute that? So this 3 into 1 plus 0 into 0 plus 5 into 0 will give me the value of 3, right? Similarly, I have calculated all the ZJ values, and now I have to calculate the CJ minus ZJ value, right? Okay, so what is Cj minus Zj value? So 3 minus, so this 3 minus 3 will give me a 0. Okay, so 5 minus 5 will give me a 0, right? So this 0 minus 2 will give a minus 2, 0 minus 1 will give me a value of minus 1, and again 0 minus 0 will give me the value of 0. Now you can note that there is no negative positive value over here, right? And we can say that the obtained solution is the optimum solution. And what is the most important point is that the value of x is coming as this 1000, right? Value of y is coming as 500, and this is the total profit made. Now you can see that from the previous table the profit is improved. The previous table profit was 5400, and now it has been improved to the 5500. And also remember that this particular S3 is also coming as 100 because this is the unused resource. So I hope that you have got all this method. Thank you.